So the big question today is, what are functions? So we're going to talk about what are functions, how do they work, how do we determine them, and what are some things we know about functions. Okay, so the first thing we need to do is we need to define a couple of vocabulary words. So what is a relation and what is a function? So a relation is just basically any relationship that goes between inputs and outputs. So equations, right? Numbers you put into a calculator. These could all be different types of relations. A function is a specific relation where there's exactly one output for every input. So again, every input has exactly one output. The big idea is that the input cannot repeat. Now, typically, we're going to use input x to represent that and y to represent an output because a lot of relations are actually going to be graphs. And remember, graphs are made up of points that we can use ordered pairs to create. So that's your x and y. So x would be your input, y would be your output. So if we take a look at the first example, we have three different types of relationships here, and we want to determine if it's a function. And what you can do is you can look at the set of ordered pairs, and you can easily look at your x and your y's. You can create that into a table if you want, if it helps you really see if it repeats or not. And then we have this what's called a mapping diagram, where you can see inputs mapped to outputs. But remember, the big idea here is that your x's cannot repeat, right? So we're only looking at the numbers on the left of each ordered pair. So we want to see, do these numbers repeat? Well, -3, -2, -1, 0, 1, they're all different. So we are okay. The y doesn't matter, right? They are all the same numbers, which is fine. What matters is that every input, the x, only has one output. So each x can only have one unique y, but they can have the same y's, which is fine. So here we would say yes, because no input values repeat. And you can also say x values. Now compare that to part B. Again, we don't care about the y's, we only care about the x. So 1, 2, 3, 1 and 4. These repeat, so we don't want that in a function. So we're going to say this is no because the input value, or the x value, of 1 repeats or has more than one output. Okay? So we can see the same deal here with C. And again, we're going to see each input and the output, but to check if it's a function, again, just look at the x. 0, 2, 4, 6, 8, 10, nothing repeats. Beautiful. It's going to be yes. Because no input values repeats or no x values repeat. Okay, finally, how do you read this mapping diagram? Well, imagine this as a list of ordered pairs. So we can rewrite this as, well, 2 goes to 4, 2 also goes to -6, 3 goes to -6, and 4 goes to -8. So if it helps you, organize your thoughts better, you can rewrite that as ordered pairs, or you can simply look and see that this 2 is being greedy and going to 2 different y values. And we can see that right here. So is this a function? No, right? No, because the input value 2 has 2 output values, right? Or something along those lines. So go ahead and try 1, 2, 3, and 4 in the U try and figure out which ones are functions and which ones are not, and make sure you explain. Tell me why or why not. So check your answers. I didn't write my explanations here because your explanations can vary, and we can talk about that at some point in class. But it should be no, yes, yes, and no. So you'll see here what repeated? The 5s. And number 4, there's only one input value. So 1/2 is being super greedy and go to 3 different y values, so that's a no. Okay? Now, there's one other way to represent relations, and I kind of mentioned this earlier, but it's a graph. How do we check out graphs? Because graphs have so many different points, we're going to use what's called a vertical line test. And a vertical line test is exactly what it sounds like. We're going to look at vertical lines, so these up and down straight lines. So at each, when you're basically passing through vertical lines, and you can imagine, you take a ruler, right? And you're just swinging it over here from left to right on this function. And every time this dotted red line hits your graph, it should only hit the graph at one point, and that's how we know it's a function. Versus if you look here, if I'm, for example, going left to right again and bringing down my vertical red line, here we've got two intersections. That's not okay. That means at this one number, it could be 1 or 2 or whatever, it's got two x values. So that's why it's not a function. So if we take a look at the next couple examples, we're going to use that vertical line test to tell if the graph is a function. And again, vertical lines. So if we take a look at this, if I imagine just passing through my vertical line that way, actually I can make this a little better. Let me try that again. So imagine taking this line, right? And you're just slowly going through every part of this graph. And you're just double checking, do I hit the points more than once? And here, no, we don't. So yes, this is a function because it passes the vertical line test. Taking a look at F, again, you can imagine just starting wherever the graph starts, and I like going left to right, but it's up to you. And then here we only hit one point, but right here, we've hit 1, 2, right? If I went even further, I'll see again I'm hitting 1, 2 points, and that is not okay. So this is going to be no because it doesn't pass the vertical line test. Okay. One thing I want to mention about these two graphs you see here, there are two different types of graphs. One is a continuous line or a curve, and the other is just these separate dots. E is what's called a discrete graph, and F is what's called a continuous graph. And we're going to revisit this idea later on in the notes, but you're going to hear me use those words. So discrete means you have specific points and dots that you don't connect. Continuous means you connect all those dots to create a line or a smooth curve. Okay. Anyway, go ahead and try those U-try problems, and let's see which ones are functions and which ones are not. And again, if you need to draw on that vertical line test, feel free to do so. Or use a ruler, use your pencil, and pass through the grid. So hopefully you spotted the one that is not a function is the circle in 7, because we're going to hit at least 2 points in some spots when we use that vertical line test. All right. Moving on to what's called domain and range. So domain is just a fancy way of saying the set of all possible input values. And remember, input values are x. So domain is everything that x could be, while range is everything that y could be. So if you imagine a function as like this machine, whatever you input, and I realize I use the opposite colors, but whatever you input is the x, and whatever you output is going to be the y. All right. So domain and range can be written in two different ways. It can be with a discrete function, sets of data, so actual numbers, versus a continuous function like h, it'll be a range of values using your less than and greater than signs. Okay, so we want to be careful with that. So what I always like to do is I always like to bring it to the axis that we're working on. So if I'm looking for domain, I'm going to use red for domain, and you can use D to represent domain, capital D. I want to go down and see what are these actual x numbers. So with the dots, it's actually super simple, right? I can look at this number, this is -3. This number, it's -1. Coming up to the x-axis, this is +1. Coming up to the x-axis, this is 3. So those are my 4 numbers. I want to make sure I'm using set notation, which is this curly Q bracket, and I'm going to go from least to greatest. So starting on the left, -3, -1, 1, and 3. Okay? So that is domain. Range now is what the y can be, right? So I'm looking at y. So instead of going to the x-axis, I'm going to go across until I hit the y. And again, I want to go from smallest to biggest, so I like going from bottom to top. So here's -3, and then I'm going to be at -1. Here's a +1 and a +3. So those blue dots on my axis represent the range. Again, use that curly bracket for set notation. So we're looking at the set of numbers, smallest to biggest for y, -3, -1, 1, and 3. And that's what's called the range. And that's super simple, hopefully super straightforward for discrete graphs. Continuous graphs, same idea, but instead of having actual separate dots, we're going to look at a range of data. So if I'm looking at domain, here, I want to look at where it starts and where it stops. If it does stop, it could actually go on forever, and we'll look at those examples when we get to them. But if I look at domain, here on the left, it starts at -1. And you'll see this graph is a line, right? So I'm going to go ahead and map that out as a line on the x-axis. So I'm going to keep going because I can keep coming back up to this axis until I stop right here at 3. So I want to represent this closed number line graph as the domain. So remember this from earlier on in inequalities? I can rewrite this as an and inequality. -1 is less than or equal to x for domain, which is less than or equal to 3. Okay? Versus range is the y. And remember again with the range, you want to go up and down. So I'm going to start at where is the lowest point, if there is one, because it could go on forever. And it's right here at -3. And then remember, I can keep bringing all these points on my grid to the y-axis all the way until I hit the topmost point, the highest point, which is right here at +2. Now this line in blue that I just drew is an and inequality that I want to go ahead and write down. So I'm going to go with the smallest number, which is at -3, less than or equal to y, because I'm looking at range, and less than or equal to 2. Okay? So that's domain and range. Go ahead and try it out on your own for 9 and 10. All right, so double check your work. One thing I forgot to mention, for example, number 9, if you have repeated numbers, like on the range we had 2 happen twice, 4 happen twice, you just list it once. So you don't have to list every single repeated number, it's just every unique number one time. All right, let's go ahead and take a look at our last part of the notes, identifying independent and dependent variables. So what is an independent variable versus a dependent variable? Well, the independent variable is the variable that represents the input values. And these are numbers that usually you can choose. Like you might want to say, I want to see what happens when I plug in 5 or when I throw in 7. The dependent variable then is the variable that represents the output values. And it's called the dependent variable because the output depends on what you threw in as the input, right? We can't choose an output necessarily, but we might say, I want to figure out what happens when I throw in 5 and your answer is 7, then the output depended on that 5 that you threw in to begin with. Okay, so last thing for today, looking at this example, the function c equals 6t plus 8 represents the cost c for t-shirts plus shipping. What is the independent and the dependent variable? Well, imagine this equation. What is it that, for example, I can control if I'm thinking about what I want if I'm buying t-shirts versus what would I end up needing to do based on that independent variable? So you can also tell based on the function, right? What is it that we are working with and what is it that we are solving for? All right, so let's identify the independent variable. So the independent variable is again what you can kind of choose, that's the way I like to think about it, or what we're actually manipulating. So in this case, we're thinking about t-shirts, right? We can decide, I want to buy 7 t-shirts, I want to buy 12 t-shirts, and then what am I going to have to pay you for it? Or you can look at the equation and say, well, hey, look at this. T is being operated on, right? I'm multiplying T by 6 and adding 8 to it to create this brand new piece of information, C, which is the output. So the independent variable here is T. And the dependent is going to be C. Because how much I'm paying for these t-shirts depends on how many I'm buying, right? Or you can, again, look at the equation. C is going to be the brand new number after we plug in something for T. Now, if you look at part B, the domain is 1, 2, 3, 4, and 5. What is the range? So this is saying, I want you to plug in 1 for T, 2 for T, 3 for T, 4, and 5, and tell me, what are all these different costs? So you're going to have to do that work, and I'm going to pause and do it all for you in a moment. So there I went ahead and just plugged in 1, 2, 3, 4, and 5. And because t-shirts are discrete, I can't buy half a t-shirt, I can't buy half, 1/3 of a t-shirt, I can't buy 1.8 of a t-shirt, right? Then my range is also going to be discrete, right? So my range is going to be 14, 20, oops, let me make that a little clearer, 26, 32, and 38. Because again, I can't buy pieces of t-shirts, I can only buy a whole t-shirt. Now take a look at the U-try problem and go ahead and try 11 and 12. Now I want to point out the big difference here is 11 is kind of like the example. We can only, buy a whole avocado. We can't go to the store and be like, I just want one, quarter of this avocado. Versus number 12, where we have oven temperature, and we can actually usually pick a range of temperatures. Right? The oven temperature might not be exactly 350, it might be 350.1 or 350.5 or 352 at any given time. So that changes, and I want you to think about that when you get to 12. So try these out. Okay, so hopefully 11 was pretty straightforward, right? Independent is the number of batches of guacamole we make, because we can pick that, and then A would be the number of avocados we have left. All right, and then I want you to look carefully at the range. So we got 14, 10, 6, 2, and then -2, and that's by plugging it all in. But use a little logic. Can you ever have negative avocados? You can't. So our range is actually just 4 numbers. So I'm going to make sure we pointed that out. 12, I want you to direct your attention at B, and this might have been a little tricky. So because temperature doesn't have to be set at like 350, 351, 352, it can be 350.785. We need to use an inequality to represent domain and range. Now, what was tricky here was we wanted to make sure our temperature is up to 350. So you had to figure out how many minutes does it take to get to 350 degrees. So I plugged in 350 for T because T is temperature. And I see that takes 15 minutes. So to get up to 350, we know our oven's going to be on for anywhere from 0 to 15 minutes. So that's my domain. The range is going to be the temperature. And we know we want to max out at 350. But then we have to think, well, what is the temperature to start? So I plugged in 0 for minutes. Because at 0 minutes, I want to know what temperature that's at. And that's at 65 degrees. So my range is 65 to 350. Okay, so I know this is really long, but thank you for hanging in there, and we'll keep practicing this in class.